Hello, and welcome to the CISSP Exam Prep Part 2. My name is Mark Edmead. I will be your instructor for this course. If at any point you have any questions, just go to the question comment box. So let's get started. We're going to continue discussing cryptography. We're going to talk about some additional encryption methods. So the topics for this module includes other encryption methods. We're going to talk about IPSec and how cryptography is used in the real world. So other encryption methods. Some of the terms that you need to know for the CISSP exam when it comes to cryptography is things like, what is the secure socket layer, SSL? This is a protocol that is used to provide a secure channel between the web clients and the web servers. So when you communicate to a secure website and you're doing something like HTTPS, then it's going to be using the SSL as the socket. So this is where you have the secure HTTP. IPSec is another layer or another area of the security that we can have on a network. This operates at the network layer. This enables secure connections on the internet, and it works in three ways: either host to host, host to the network, or network to network. IP security. This is a way to provide secure communications over IP. It can be used to create a virtual private networks or VPN. So VPNs use IP security or IPSec to establish that secure communication between two devices, and any communication between those two devices is going to be secure because data is encrypted. IPSec filters packets, looks at your network packets going in and out, and it can use to then filter. So only allowing certain packets coming in, or only allowing certain packets going out. So this is opposite to the firewall that only filters packets going in. IP security uses a policy database that is used to record the actual settings. So when a packet leaves a system, it's reviewed first. And so before using IPSec, the policy needs to be created. And sometimes the creation is not very, very easy. But this is to check the packets going out of the system. Like I said, it was just opposite to most firewalls, which use packets coming back into the system. So let's talk about how IPSec works. Let's say that a computer A wants a secure communication with computer B. Computer A sends an IPSec-enabled application to send the message to computer B. Computer A checks with the IP filter list first for an address or a traffic type match. If it's found, then it's applied. In other words, if it's allowed, then it happens. If the packet is not there, if the match is not there, or the address is not there, then the packet is dropped. Computer A then starts negotiation with computers B. So they do this secret key exchange. They create a secure connection, they create a session key, and then packets A leaving the computer A is then signed by the IPSec driver. We do this because we want to deal with data integrity, and also that data may be encrypted as well. When the packet arrives at computer B, they are checked for integrity, and then they are decrypted. So routers between the computers do not need to have the configuration set for IPSec. It really doesn't matter because the routers are only going to route the data. They don't really care about IPSec. But firewalls may need to be allowed to allow IPSec traffic because certain firewalls may be blocking IPSec traffic configuration. The two protocols that we use in IPSec, one of them is called authentication header, or AH. This is where it adds authentication and integrity. And the other one is called Encapsulated Security Payload, or ESP. This provides authentication, integrity, and confidentiality. There's also this term called security associations. Because remember, we talked about computer A talking to computer B. Well, the security association is a secure links that define how that communication is going to happen. And security association is a combination of the IP address, and SPI that we're going to talk about in just a little bit, and the security protocol that's being used, either AH or ESP or sometimes both. The SPI is called the Security Parameter Index. This is a cookie or a piece of information that is handed out by the receiver of the security association. that's something like a unique identifier that makes sure that, hey, when you want to communicate with the receiver of the SA, there's a cookie that is in exchange, and that's how the validation is then done. Some of the other terms that we need to know for this chapter is things like the Internet Key Exchange, or the IKE, because this is where the AH and the ESP need to share a secret key. So the Internet Key Exchange provides a method of negotiating these keys in secrecy. Another term that we learn is the ISAKMP. This is the Internet Security Association and Key Management Protocol, which is based on a framework called the ISAKMP, and this is where it implements another key exchange called the Oakley. So again, no need to get into those specifics, just know the terminology of what the Oakley is and basically how it associates with the encryption and the exchange of keys. So one of the challenges with encryption is this, and we'll talk about now the real world situations where cryptography is used. Now, government and other law agencies might require access to transmitted information. The interesting thing about encryption is that when the encryption is there, when somebody sees that the data is encrypted, people get really curious, like, why is it encrypted? And of course, the government wants to know if any data is leaving, let's say, the United States and going to a foreign country. So there are restrictions as far as exporting information or applications that encrypt the data. So you really need to talk to the legal department to determine what the current legal issues are with encryption and how strong can encryption be. Because sometimes if you encrypt something that is too strong, the government won't let you do that. And so you really need to look at some of the laws regarding that, because they might require encryption keys to read those messages before they go out. However, citizens need privacy and protection from illegal and unauthorized surveillance. This is the big problem that's happening in China now, where they're restricting the ability for the Chinese to use websites like Google because of potential issues of data going outside. They also restrict things like instant messaging because they want to keep control of the transmitted information outside the United States. We have this thing called the Escrowed encryption standard. This is what is used as something called the Clipper chip. This is actually based on the skipjack algorithm that we talked about earlier. And it was designed by the NSA as a tamper-proof chip for encrypting data. So the reason why they came up with this Clipper chip is they said, look, we, the NSA, we, the U.S. government, want to have the keys that you use to encrypt your data, so that therefore if we need to encrypt any transmissions, then we can go ahead and use that key. Now, it needs to be something that you have to get a court order for them to use it, but the challenge is that a lot of people did not want to provide the NSA or the government with their keys because, again, it's Big Brother watching. And it also uses skipjack, which is actually a very weak algorithm, so it's really not very secure. So again, for the CISSP, you have to know about the Escrowed encryption standard that uses the Clipper chip. There's also something called the FAIR Cryptosystem. This is something that was developed by Silvio Micali, and this is where you take the private key and you divide it into multiple parts. Then it's distributed to various trustees. So if the authorities have the right to decrypt the message, they can obtain all the different components of the key and then read the message. So this is just taking the private key and breaking it up into multiple parts, 5, 6, or 7 parts, and then giving it to different people. Again, separately, they can't do anything about it, but if they need to combine all of those keys, then they can go ahead and decrypt that information. So do you have any questions on this? If you do, please use the comment and question box. Thank you for joining us. This concludes this section on cryptography.